Hi guys, Dr. Tim Kruse, teaching a little algebra here. Today we're going to test a table and we're going to see if that table is exponential, and if it is, we're going to write a formula and graph it. Now let's back up just for a minute and let's look at a linear table. This is another lesson, but let's back up and remember how we did that. So given a table of values, maybe we're trying to figure out whether it's linear, you see the word line right there, that it forms a line, or if it's exponential, which is a curve. All right, well, this one is linear. Now, how do we prove that? Well, we try to examine the y values and see if they are increasing by the same amount each time. If it's exponential, they won't increase by the same amount each time. But if it's linear, they'll go up the same amount each time. That's what slope tells you. Slope tells you how much the y goes up as time goes by. All right, so maybe it's not as easy as this one here, 5, 10, 15, 20. It's obvious they're going up by 5 each time. But maybe you have some harder data values like 5.7, 10.3, 15.9, and you can't just look at it and obviously see what it's going up by. Well, there's a trick. If you can't tell what they're adding each time, you just throw it in reverse. Start here at the back and throw your car in reverse. And instead of trying to figure out what we're adding each time, just throw it in reverse and see what they're subtracting each time. That'll get you to the same place. So 25 minus 20, that's a difference of 5. 20 minus 15, that's a difference of 5. 15 minus 10 is a difference of 5. And 10 minus 5 is a difference of 5. So they're subtracting 5 if I'm going backwards, which means they're adding 5 if I'm going forwards. All right? So it's real easy to test for linear if you start at the back end and throw your car in reverse and see what they're subtracting. If you figure out what they're subtracting, then you know what they're adding. The differences are the same. But what we're testing is exponential. All right, I want to test this table and I want to see if it's exponential. So it looks like they're going up by ones. Maybe a week goes by, 2 weeks, 3 weeks, 4 weeks. As time goes by, this y amount is increasing, 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 increasing. All right, now I'm going to test it and see what they're increasing by. Now, if I test it for linear, I start back here and I subtract and I get a huge number. And 270 minus 90, that's 180. 90 minus 30 is 60. 30 minus 10 is 20. It's not linear at all. All of those differences are different. So something else is going on here. So I'm going to test for exponential. If it's an exponential function, the y values, instead of adding something each time, they will be multiplied by something each time. Like it will double, 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 or triple, 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 which is what's happening in this case. 10 times 3 is 30, 30 times 3 is 90, 90 times 3 is 270, and so on. Now, your tables won't always be this easy. It won't always be obvious just by looking at it that we are multiplying by 3. You know, this might be 10.47, 31.49, or whatever. So the data might be more difficult. So what do? Well, if you can't obviously see what they're multiplying by every time, again, you just start at the back end here, throw your car in reverse, and instead of trying to guess what they're multiplying by, start here at the back end, throw it in reverse, and divide, 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 divide. That'll get you the same number. 810 divided by 270 is 3. 270 divided by 90 is 3. 90 divided by 30 is 3. 30 divided by 10 is 3. Going backwards, they're dividing by 3 each time, which means going forwards, they're multiplying by 3 each time. That's how you figure out what they're multiplying by. Start at the back end and divide, divide, divide. So every time we divided, we got 3. That's actually, I'm going to call it our multiplier. Technically, it's called a growth factor. So we're going to start, here's time equals 0. We're going to start with a y value of 10, and we're going to multiply it by 3 a whole bunch of times. And that's what your formula says, all right? Your equation is, okay, how do I find the y? Well, I start at 10. That's my initial value. When x is 0, this is the amount you start with. I'm going to start with 10, and I'm going to multiply it by 3 a bunch of times, all right? So 10 times 3 to the whatever x is. So, for example, 10 times 3 to the 0 equals 10. 10 times 3 to the 1 equals 30. 10 times 3 to the 2 equals 90, and so on. You can plug in any x and do the multiplication, and you'll wind up with the y value that matches that x. So after 2 years, 10 times 3 to the 2 years, I will have 90 whatever dollars. Maybe you invested $10, and 1 year later it was $30, and 2 years later it was $90, and then here 4 years later it skyrockets to $810. All right, that's the miracle of compound interest, exponential growth. Eventually it starts skyrocketing. So remember the number right after the equal sign, we like to put our initial value there, what we started with. And the number you're multiplying by over and over and over again, 10 times 3 times 3 times 3 times 3 times however many 3's you want. I say multiplier a lot. All right, technically it's called a growth factor. Factor means multiply. This is a fancier way of saying multiplier. It's a growth factor. It's growing, all right? The amounts are getting larger, 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 larger. So it's exponential growth. And we call the number that we're multiplying by each time a growth factor, all right? Now note, it's important that you note that the x's are going up by ones, all right? So if the x's go up by ones, it's actually very easy to write the formula. It's what you started with times whatever you're multiplying by each time. Now I'll show you a table later that goes up by 2's. And if it goes up by 2's or 3's or 4's, well, that kind of messes up your equation. But if it's a nice table that goes up by 1's on the x's, it's nice and easy to figure out what the equation is. All right, now since we're here, I'm going to show you how to write the equation, this equation here that we figured out by hand. I'm going to show you how to do it on the TI-84 since we're here. So I'm going to use this data right up here that you already have written down. And first of all, just make sure your calculator is kind of clean. Make sure there's nothing in the y equals. All right, I don't want anything messing with my data. And then to enter the data, we go Stat and choose Edit. And there's our table. If there's anything in the table, just delete, 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 delete. I always like to show that if you accidentally go too high up there and you're on L1 and you hit delete and you lose that list, it's easy to bring it back. Just hit Stat and go down to Setup Editor, hit Enter one more time, and it brings back your list 1. So don't panic if you accidentally delete a list. All right, I'm going to go ahead and enter my data 0, 1, 2, 3, 4 in the x's. 0, 1, 2, 3, 4. And then let's enter the y's, and that was 10, and then it triples every time. So 10, 30, 90, 270, and 810. See if I did that right. Oops, missed 810. 810. How's that? Okay, that looks better. All right, once you enter your data, put your x's in list 1 and put your y's in list 2. Once you enter your data, you just tell the calculator to go to Stat again, Stat, and tell the calculator to calculate. So one step to the right, and tell it what you want to calculate. Now in the past, if it was a line, we used linear regression. So linear regression is not what we want here because we don't have a line. We have exponential regression. So I want a exponential regression line, and that's option number 0 there. Exponential regression formula. So this is going to be the formula for the curve. Hit enter. And it says, hey, just double checking, did you put your x's in list 1? Yes, we did. Did you put your y's in list 2? Yes, we did. So I'm going to skip those, skip frequency, skip that one, and just get down to calculate and ask it to calculate. And here it writes the formula for you. It says A is 10, so the 10 goes right there where the A is. It says B is 3, so the B goes right there. The 3 goes right there where the B is. So it's y equals 10 times b to the x, which is exactly what we got right here, 10 times 3 to the x. All right, now that we have that equation, let's go to our y equals button, and let's put that equation in. So 10 parentheses 3 to the x. How'd I do? Yep. All right, I want to graph this. Now let's just cheat and use the x's that they have in the table. So let's just go 0 to 4 on the x's. So I'm going to go to my window and I'm going to say, well, I just want my x's. Oh, I already said it. I just want my x's from 0 to 4. Usually this says something like -10 to +10. Change it to 0 to 4 so it matches the table. Now we're not going to mess with the y values, all right? Don't mess with them. We're going to use zoom fit, which is option 0. And on zoom fit, if you set the x's in your window and then hit zoom fit, it'll figure out the y's for you. Now just hit enter and wait. See, it's thinking up there, thinking. And it puts a line right through there, a line, I keep saying line. It puts a curve right through there. Now notice that I've got the dots on there. Now how did I do that? Well, if you go back to y equals, You see how I have plot 1 highlighted? Plot rhymes with dot. That's how I turn the dots on. If I want to turn the dots off, I go up to plot 1 and I deselect it. So I hit enter and now it's not selected anymore. I go back to graph and I have just the curve without the dots. Okay, now let's do it the other way around. Let's go back to y equals. All right, maybe I want the dots on. I'll go back up to plot and turn the dots on. So I selected plot, and maybe I don't want to see the line. Well, you see where you see there, sorry, I'm stuttering. You see where the equals sign is highlighted? Well, let's get on there. Well, uh-oh, now I've messed up my equation. Second, insert 1. Okay, I'm back. All right, let's go stand on the equal sign and let's deselect it. So I hit enter to deselect the equal sign. And now the only thing I have turned on is the dots. Graph, and there's your dots. You want to bring the line back? Just stand on the equals, select it, hit graph, and there comes your line right back. All right, now if you're not getting the same dots that I am, you set all that up right here in stat plot. So I go to second stat plot. I want to deal with plot 1, so I choose it. I have it turned on, and I chose the type right here, which is a scatter plot. It just has a bunch of dots on your graph. You can also do bar graphs and box and whisker graphs. We're just going to choose regular old dots. It says, are your x's in list 1? Yes. Are your y's in list 2? Yes. What kind of dot do you want? I chose this dot right here, but you can use other forms as well. So in stat plot, that's where you set up what you want your dots to look like. Back to graph, and there we go. All right, if you guys want to try one on your own, here's one to try. Just pause the video and work it out on your own. See if you can come up with an equation. See if you can graph it with the dots and everything. All right, so hopefully if you paused, you tested it to see if it's exponential. So I'm trying to guess what they're multiplying by each time. So what I do instead is I start at the back end there. I start at the back end and I divide. I say this number divided by that number, that's 2.5. 1250 divided by 500, that's 2.5. 500 divided by 2, and so on and so on. Going backwards, it looks like they're dividing by 2.5, which means going forwards, they must be multiplying by 2.5. 2.5 is our multiplier, technically called our growth factor in the parentheses here. As long as the x's are increasing by 1, all right, your multiplier will be your growth factor. This number here right after the equal sign, that's what you started with. When time was 0, when no time had gone by, you had $80 in the bank, or whatever we're measuring. So we started with 80 and we multiplied it by 2.5 each time. This stands for time, how much time has gone by. So if you want to get this 3125, well, you just plug 4 years in for x. After 4 years, 80 times 2.5 raised to the power of 4 will give you $3,125 after 4 years. All right, your ratios are the same. So if they're multiplying by the same thing every time, that's exponential, either growth or decay. You got to look at what's happening. These numbers are getting larger, 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 so that's growth. If they get smaller, 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 then that would be exponential decay. All right, now remember to clean this thing up. Go into y equals. Let's just clean this thing up and go into stat, edit, and let's clean up your list. Delete, delete, delete. It's kind of slow, but it gets the job done. Delete, delete, delete. There's other ways to clear your list. You guys can figure it out. Enter your new data. All right, enter data. I got the x's over here, the y's over here. Stat, tell it to calculate, and we're going to go all the way down to an exponential regression formula. A regression for exponential. Check, 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 check. Let's have it calculate. And it says my equation is a is 80, b is 2.5, so it's 80 times 2.5 raised to the x. All right, that was pretty easy to figure out. 80 times 2.5 raised to the x. Okay, put your equation into y equals. Just copy your x's off your table, so 0 to 4 on the x's. Go to Window, set it 0 to 4. Don't mess with the y's, just do zoom, and then option 0, whoops, I went the wrong way. Option 0 is zoom fit. Let it think. I already have my dots turned on. Another thing you can do, by the way, is you can hit trace, and it will go dot to dot and tell you the coordinates. So right now it's sitting over here at 0, 80, and I go to the right. Now it's at 1, 200, 2, 500, 3, 1250, and 4, 21, 4, 31, 25. So you can kind of check your coordinates there if you like. Again, if you want to shut off the dots, just shut off plot 1 and hit graph. And if for some reason you want the dots, turn them back on, but you don't want the line, then go stand on the equal sign and deselect it, hit graph, and there's just your dots. Again, you can hit trace, and it will kind of go dot to dot and tell you the coordinates of each dot. All right, let's do a couple more, and then we'll use our formula to maybe go a little farther than the table goes, maybe go out to 5 or 6 or 7, and make a prediction about the y, what the y will be several years later. But let's practice a couple more tables here. So go ahead and pause if you want to, test it and see if it's exponential. Write you a formula, either by hand or using the graphing calculator, and then maybe graph it on the graphing calculator. All right, so it's not obvious what's happening here. I don't know what they're multiplying by every time. So I start at the back and I throw it in reverse and I divide. 80 divided by 200 is 0.4. 200 divided by 500 is 0.4, and we continue and continue. So going backwards, we're dividing by 0.4, which means going forwards, they're multiplying by 0.4. You can check it. 3125 times 0.4 gives you 1250. 1250 times 0.4 gives you 500. Notice it's getting smaller, 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 smaller. The y value is getting smaller, so this is going to be exponential decay. We know it's exponential because they're multiplying by the same number every time. And we know it's decay because the y values are decreasing. Now, as long as the x's are going up by 1, all right, you can write the formula pretty easily. It's what you started with times what you're multiplying by. So we're starting with 3125 initial value times your growth factor, 0.4, raised to the x. And using this formula, you can get any y value in the table. Just plug in, say, 3 for x. 3125 times 0.4 to the third will give you 200. All right? So when you started measuring, you had 3,125 of something. A year later, it was a lot less. 2 years later, it was a lot less. 3 years later, it's a lot less. And eventually, you're going to have pretty close to nothing. And of course, the graph, you guys should know this by now, is decreasing, decreasing, getting lower and lower and lower as time goes by. You can always hit trace and double check your points. 0, 3125. A year later, it goes down to 1250, so now it's down here. A year later, in year 2, it's down to 500, and it decreases as time goes by. Okay, now be careful. Sometimes they try to trick you. They'll give you a table of data that's not exponential. That's why we're testing it, just to see if it's exponential before we put all that work in. So if I'm looking at this data right here, and it looks like it's increasing, 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 it kind of looks like it might be exponential growth. I can't tell what they're multiplying by, so I'm going to start at the back end and throw it in reverse, and I'm going to divide. 36 divided by 18 is 2, so it looks like they're multiplying by 2, but let's check it again. 18 divided by 7, that's 2.57. 7 divided by 3, that's 2.33. So since they're not multiplying by the same number, same number, same number, it's not exponential. Now, there is something going on here. It's definitely growing, 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 but I can't necessarily say it's exponential because they're not multiplying exactly by the same number. Okay, one last thing before we kind of try to predict the future. How much will you have in 8 years, 10 years, 12 years? Sometimes they'll try to trick you again. This is a trick, all right? Notice that they're going up by 2's in this table. So time is going by 2 years at a time, all right? Now, that's not a problem. We can still write an equation. We just can't kind of do it by hand like we've been doing. So first of all, let's test it. Test and see if it's exponential. All right, let's pretend I can't tell what's going on there. So I start at the back end. I throw it in reverse and I divide. 270 divided by 90 is 3. 90 divided by 30 is 3. 30 divided by 10 is 3. Okay, so they're dividing by 3 going backwards, which means they're multiplying by 3 going forwards. Since they're multiplying by 3 every time, that's great. It's exponential. I look at it and it's growing, growing, growing. This is an exponential growth table. All right. Now, the way we've been doing it is we said, well, it's what you start with, 10 times your multiplier, times your growth factor. So it looks like it's 10 times 3 to the x, but it's not because we're not going by ones in the x. That kind of messes up our multiplier, our growth factor. All right. So really the only way to define this equation is to go to your calculator. Here's the actual equation. All right. It's still going to be the initial value of 10. That's not going to change. But if you're going 1 year at a time, you're only going to multiply by 1.73. It's kind of weird. All right. Note that 3 is not your multiplier since your x's did not go up by ones. So grabbing my calculator here. All right. I've got my data in there. And I tell it, okay, using the data, let's calculate exponential regression. Option 0, enter, enter, enter. And there's my equation, 10 times 1.73 raised to the x. Kind of a messy equation. I'm going to set my window to go 0 to 6 because that's what my x's are in my table. I'm not going to mess with the y's. I'm just going to hit zoom and then option 0, zoom fit. And I'm going to let it think. And it's going to show me, there it is. It says it's growing, growing, growing. And again, if you want to double check your points, hit trace. And it says you started at 10. When no time had gone by, you had $10. A year later, oops, oh, that's 2 years later. See, we're going by twos. It fooled me too. 2 years later, you had $30. 4 years later, you had $90. And 6 years later, you had $270. That's up here in the corner. We can't quite see it. So this is kind of an odd table because it doesn't go by ones. So the equation is a little bit harder to come up with. All right, this is our last problem for today. So, now that you guys know how to do all of this, let's say given this table, 0 to 4 years go by, and your investment goes up from $110 up to $422.58. And you guys know how to do this already. You check your table by throwing it in reverse and going backwards. So this number divided by that number gave us 1.4. This number divided by that number gave us 1.4. And we work our way backwards through the table. So working backwards, it says they're dividing by 1.4, which means going forward in time, they're multiplying by 1.4. Check your x's. All right, our x's are going up by 1, so this is easy to write. I just say, well, what did I start with? Times 0, I started with $110. So my initial value is $110 times our multiplier here, our growth factor of 1.4 raised to the x. There's our equation. Now I threw some, story problem letters at you because lots of times they don't want you to use good old x and y. They'll say, after a certain amount of time, your investment was worth this value, maybe V for value. All right, so X is usually time. Anytime they ask you when, they're talking about the X number or T. And then, so what was your value after a certain amount of time? All right, so, they can ask the question a couple of different ways. They can say, well, how much was your investment worth after a certain number of years? Well, that's the easy way to ask the question. If they tell you what X is and they ask you what Y is, you're just going to go over here to your table and look it up. Now, you always want to check your table setup right here. So second table setup, make sure you're starting at 0 and going up by ones. All right, just like your table is right here, starting at 0 and going up by ones. So once that's set up, go look at your table and you see at 0 years, you had $110. 1 year later, you had 154, 2 years later, 3 years later, 4 years later. That's as far as our paper table goes, but this table here goes on forever. So I could tell you how much you have, 9 years later. I would say V of 9, because T would be 9, if I scroll down to 9. If T is 9, then V of 9 is, sorry, I'm shaky, is 2272.70. And so on. I can go down to any year that I want. 16 years later, I have this much, and so on. All right? Now, that's the easy way to ask the question. If they tell you the X, if they tell you how much time has gone by and they ask you how much your investment's worth, that's easy because you just scroll down to whatever X they're talking about and look at your Y over here on the table. If they ask the question backwards if they say, hey, I'm going to tell you what the y value is, I'm going to tell you what your value is, and I want you to tell me what the x is, well, lots of times that's a little bit tougher. So the question that I pose is when, that's going to be your x value, your time, when is your investment exactly $800? That's what makes it hard. Not about $800, but exactly $800. Well, let's go back to our table here and let's kind of scroll around. Now notice I'm looking at value. I want to know when value is 800 bucks. One way to do it is to, oops, I lost my, there we go. One way to, oh, it doesn't like to go up the y's. There, I just figured that out, so I'm going up the x's here. One way is to go over here into the y's and just kind of watch when it hits 800. And there it is right there. So it goes from 591 to 828. So 800 is in between those two. That means it's in between year 5 and year 6. So I'm going to kind of show you the hard way to figure this out first, and then I'll show you an easier way, and you can do it either way you want to. So I know that after year 5, we hit 800 sometime. All right, I'm going to go back to table setup, and I'm going to say, okay, I want to start at year 5, and I want to take smaller steps. Instead of going a year at a time, how about we go 0.1? We're going to go 1/10 of a year at a time. We're just going to make smaller steps. Instead of going up a whole step at a time, we're going to go 1/10 of a step at a time. Look at your table. So it's starting at 5, and it's going up 0.1 at a time. We're taking smaller steps. Go back over here to your y, and just kind of watch when you hit 800. Whoops, there it is right there. So somewhere between 774 and 800.84, we hit 800 exactly in between those two y values, which means somewhere between 5.8 and 5.9 years. I know it's before 5.9 and it's after 5.8. So I'm going to go back to table setup, and I'm going to start at 5.8, and I'm going to take even smaller steps. Table setup, I want to start at 5.8, and I want to take even smaller steps. Instead of 1/10 of a step each time, let's go 0.01. Let's take 100th of a step each time. Back to table. And now, see, I started at 5.8, and I'm only going up 100th of a step each time, 0.01 at a time. I'm taking tiny, tiny, tiny steps. I want to watch the y value and scroll until I see 800. Whoa, there it is right there. I'm getting closer. So I know it's between 798.15 and 884. That means it's between 5.89 years and 5.9 years. I'm going to start at 5.89, and I'm going to take even smaller steps. So 5.89, and instead of 1/100th of a step, let's take 1/1000th of a step. Back to our table. Like I said, this is kind of the long way, but some people like it. And we're getting super, super, super close. All right, I'm going to go one more time. I know it happens after 5.896. So 5.896. And I'm just going to go one more time and see if I can hit it right on the nose. 0.0001. All right, I'm taking even smaller steps. Let's see how close we get here. And there, gosh, we could keep going, but that's about as close as we're going to get. So after 5.8969 years, you have $800. Okay, that's kind of the long, slow way of doing it. There is a quicker way. And the quicker way is called crossing graphs, all right? If I put my original exponential equation in, all right, it's going to show a curve. It's going to show a curve going up, all right? I want to know when that curve going up is 800 steps up in the air. I want to know when it is $800. All right, so I'm going to put my curve in there. Starts at 110. It's multiplied by 1.4 a bunch of times. Let me just take a look at that. I want to set my window first. I got to see how many years do I want to cover. Right now it's only 4 years. I don't think that's enough. I'm going to go 0 to 10 and just take a look at the graph. And let's see. Let's do zoom fit. I forgot. And wait for it. And here's your growth. All right, it's growing as time goes by. Every year that goes by, it gets higher and higher and higher. Okay, that's a picture of it over the first 10 years. You see you have 10 dots down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. We might have to go further. We don't know. Pretend you don't know. All right. Now what I want to know is when is your x? I want to know which one of these dots down here. What year was this curve 800 steps up in the air? So I'm asking, when is it 800 steps up in the air? What I need to do is make a second line that is 800 steps up in the air. So let's say this is 800 here. I want that line. I want to graph that line so it goes across and hits this curve. And wherever it hits that curve, that's where the curve is 800 steps high. It's called the crossing graphs method. So I'm going to make my second equation as high as I need it to be. I need it to be 800 steps high. And I'm going to hit graph. And there it is right there. This is 800 steps high all the way across. No matter how much time has gone by, this thing is 800 steps up in the air. Now where does it cross the curve? Right there. That's called an intersection. I'm going to calculate the intersection and just see where they cross. Now usually if there's just two curves on the graph, you don't have to answer all these questions. You just keep hitting enter. If there's more curves than two on the graph, you have to answer those questions. And it says the intersection is 5.8969. That's what we said, 800. So after this many years, you are 800 steps up in the air. So the answer to our question, we did it two different ways, kind of a slow way and a fast way. The answer to our question is, this is when we'll have $800, a little less than 6 years. So after 5 years and most of another year, we'll have $800. Okay, again, it's your choice how you do it. The first way that took kind of a long time, we kind of bumbled through the table. We said go by steps of 1, go by steps of a tenth, a hundredth, a thousandth. That gets you pretty darn close. Sometimes you land right on it. And that's kind of, lots of people like to bumble through the table and figure out the answer. But a quicker way is called the crossing graphs method. So put your curve in equation 1, and then put how high you want that line to be in equation 2. And wherever this line cuts across that curve, you just find the intersection. It'll give you these coordinates. And this is when it hits this value. All right, that's it for today, guys.